How's it going? You made it. We're at the end, almost. Let a couple other people trickle in here before we get started. But we're excited to be up here doing, I guess, our 11th annual Trends from the Trenches, and that's really something, actually. Given that I just celebrated my 11-year anniversary with BioTeam, so there's that. So, all right, so we'll go ahead and get started. So we've got 90 minutes of fire hose to aim at you. So we'll get that going. So first and foremost, I am not this guy, clearly. Chris Dagg started this. He's been giving the talk for over 10 years. He had to bow out this year for personal reasons. And also, I think he's actually been wanting to get out of it for the last 5 years. So he finally pushed over the edge. So, I think what everyone has always come to expect from this talk is it's always been focused on blunt, honest, practical lessons learned from real world projects. And as consultants, we get to see a whole lot of different things, different groups of people on multiple environments, and see how people tackle similar challenges. We can generally speak in public about things with no filter, no BS. Fairly honestly, because we're consultants, our goal is to help everyone. So I'm not Chris, I'm Ari. I'm BioTeam CEO. I'm a scientist, technologist, been with BioTeam for 11 years. I can't replace Dagg. I'm not even gonna try. I'm gonna do this in my own way. And in fact, it takes 3 of us to replace him. So we're gonna go in sequential order here, myself, then Adam, then Anna. And hopefully it'll be an interesting journey for y'all. So first, we're hiring. So spread the word. Our team's growing. It's exciting. We've got a ton of really great work going on. So if you know anyone who is looking for an interesting job, go to our careers page. So I love this slide. This is from Dagg's last year Trends for the Trenches. This is the thought excreter magic quadrant, where there's competence domain insight across the x-axis and can talk bluntly in public. The bottom line is that we're not up here to sound smart or intelligent. We're here to just sort of give our view of the market very plainly to you all. There's a lot of other people who are smarter than us and have a lot more interesting thoughts that are sort of listed across the top there. So but what this is hopefully sort of a pure view of where we are. So I'll set it up. What's the big picture? So in general, why do we do what we do? Why are we in scientific computing? Why are we in bio IT? And I'll break it down to really what it comes down to, which is health, human health. And so scientific discovery really drives modern medicine, right? It gets us up in the morning. It's sort of the reason why we at BioTeam do what we do. Interestingly, human lifespan hit a maximum in 2019, right before the pandemic, 76.7 years in the US. And this graph shows a bunch of the other countries and where they hit. But what's really interesting is if you go back to 1865, the advent of germ theory, using antiseptics in surgery, washing your hands, doubled human lifespans. That was one of the most significant human medical advancements in history. And since then, vaccinations, epidemiology, anesthesia, antibiotics, and others have all really been driven by basic life sciences research and applied to human health. So what's happened really is, the slide won't advance. There we go. So there's the lifespan and what we call health span is now out of sync, right? So health span really is sort of the percentage of life that one is considered healthy. It's quality of life you can almost measure, right? And healthy means different things to different people. If you look at sort of the largest comorbidities in the United States, there's sort of this common list of things that are a problem and the ages of onset. The reality is that the average age of health decline in the US is about 63 years old versus 76 years of lifespan. So most of us end up living about 20% of our lives in an unhealthy state with a lower quality of life. And so what this has happened in our society is it's resulted in soaring healthcare costs, increased burden on medical economic systems as a population ages poorly. And so really, I think where everyone's been driving for a while is that medical science needs a new focus. Historically, the best outcome of medicine was not dying. And sure, great, but medical science has advanced to the point where that focus isn't as relevant anymore because it's less likely to die slightly. So we need new breakthroughs that are more focused on people being healthy and living a higher quality of life for longer. And likely focusing on that and lifespan are somewhat linked, as you would imagine. And modern diagnostics computational methods have already started driving towards this, which is really where I'll call it the vision of precision medicine comes from, which is starting to really focus down on what an individual's issues are, so that it's not such a one-size-fits-all with a whole bunch of side effects that everyone has to manage, and a whole long list of side effects in ads on TV for medications of all the horrible things something can happen to you if you take this drug, but it'll do this for you. Imagine if that wasn't a big deal. So there's a ton of precision medicine going on, but at the bottom line of this is that it takes a whole lot of data collection, a whole lot of data analytics, a whole lot of infrastructure, and a lot of expertise to even approach that. And that's sort of where we're at right now. So if you back up and look at data generation as a whole, according to the interwebs, as of yesterday, estimated 120 zettabytes of data total for the human race has been collected to date. That's an enormous amount. I'll let you guys look up what a zettabyte is if you don't know. But 23 of those were last year. And so that's just an enormous amount of data. Now, this includes everything. It includes your smartwatches, it includes cameras in the room, it includes like stoplights, all those things. But that's about 10 gigabytes per person per day times 8 billion, right? So there's a whole lot going on there. Now, if you narrow that down to our space, healthcare and life sciences, the laboratory and health diagnostics and technology innovation has been accelerating for quite a long time. I think most people have seen this sort of cost per human genome graph from NHGRI at NIH, where the cost to generate a genome just keeps falling, like way beyond Moore's law. And I think we all agree that Moore's law is no longer relevant for lots of reasons, but it's an interesting comparison. And so the rate of innovation in generating data is changing way faster than technology that supports it does. So HPC and IT technology tends to work on life cycles of 3 to 6 years, and this is changing on the order of months, sometimes even faster. And the cloud has enabled way more rapid cycling, but sort of at an increased cost and complexity of the ecosystem. And then you've got, sensor data like this thing, this monitoring everything that I'm doing right now. And all that sort of pushes up the complexity of data and the relevance. And just in labs, the types of equipment that generate data has also gotten more complex. We've talked for lots of years about genomic sequencers. They sort of kicked off this whole data revolution in life sciences. But now there's all these other really cool and really important types of equipment. New ones come out, every 6 months or so. But a lot of them really are generating tens of terabytes per lab per week. And that's a lot. So, a single lab can generate a couple of petabytes of data a year. That's ridiculous, right? If you really think about it. So how do you deal with that? Naturally, my phone rings right now. What's really fascinating is that among all the basic sciences, healthcare and life sciences is among the top data generators now, right? Not from a single experiment. High energy physics has us way beat on that, right? But it's the collective amount of data being generated is a lot. And so that's created sort of this really interesting space where bioinformatics and data science have taken over that analytics space and is pretty much required to do modern research. So you really need computational sophistication in order to compete. And clinical informatics is becoming a major health diagnostics tool too. So at the end of the day, what happens, computation is a laboratory tool at this point. Right? You cannot do modern research without computation. So it's not just an IT thing. It's not just something that you're grabbing onto when you can. If your organization is doing life sciences research or healthcare diagnostics, you need advanced computing to get it done. So let's jump into a couple of trends here. So, infrastructure in biomedical research. So this is something that has long been sort of BioTeam's sweet spot. So critical infrastructure is a critical issue in 2023, and it wasn't for a bit. Big data era, sort of led to huge data generation. I talked about the sophistication already needed, and what happened is a lot of people just started generating data, hoping that one day something will magically solve the analytics problem. And so there's been a huge backlog in data to be analyzed, and that's put a huge stress on existing resources, no matter where they are, and led to a relative decrease in discovery and productivity. in life sciences. And what's interesting about that is, why do we have data? Data is the thing. Data is the thing everyone always says. But no, data is just a substrate for knowledge generation, right? So we have to get knowledge out of that to move things forwards. And so that's kind of where we're stuck in a lot of ways. There's great work going on, but that as a whole industry. And unsurprisingly, the pandemic sort of changed the game, right? Everyone went home into isolation, labs shut down, researchers were like, hey, I can pass my time by starting to analyze all this data. And then they, overwhelmed VPNs and, tried to get into their local on-premises HPC systems or cloud environments. And what happened is it ramped up way more than anyone had prepared for. Most organizations, some of these things fell over. They couldn't go in to fix it, there was clamoring for access and hours on systems, to the point where, supercomputing centers were donating their time, to help work on the backlog, especially with COVID-19. So on-premises infrastructure also became extremely expensive, way more than it ever was, and hard to manage remotely, largely because supply chain issues, which still exist today but are getting slightly better, drove up prices. You couldn't get anything delivered because the world was shut down in lots of ways, and so local IT really could barely maintain the now super stressed infrastructure. So with that in mind, let's talk about sort of on-premises compute. The reality is that in the last couple of years, it's been increasing in complexity. I think a while ago, Chris Dagg said, this was figured out. We've got this done. Compute's easy. We can stand it up. It's actually not so simple anymore. Explosion of data science, huge data sets, accelerators, co-processors, some very specific processing units, things like that, and AI/ML in particular, which is going to be one of the major focuses of this particular session, caused a previously really simple set of decisions to get super complex, right? And also there's been this sort of very diversification of CPU, backend network options, matched to use cases. And so if I try to reduce what was about 38 slides into one, trends for on-premises HPC and life sciences, there's a huge push for as many GPUs as possible. How many of you are like, I need GPUs? Yeah, a lot, right? What's interesting is that the number of clients that we have who are seriously looking at $40 million investments into NVIDIA SuperPods is almost shocking. Like everyone just sort of wants those, right? The trick, however, is that it's kind of a short-sighted point of view because not everything uses GPUs, right? This is part of the AI tunnel vision problem that these guys are going to deal with a little bit more later here. But only about 15 to 25% of life sciences codes are accelerated for GPUs. So if you buy a whole GPU system, you're knocking out like 80% of your workloads. So most institutional clusters really need to be general purpose for that reason. And if you're really thinking about CPU ecosystems, for a long time it really was just Intel. Then AMD surged back with really amazing options that help out a lot, and ARM really has come to the forefront with lower power but high intensity systems that the top supercomputer in the world for a couple of years was built out of ARM processors. And so interconnect between the nodes is still fairly standard, except that NVIDIA bought Mellanox, and those things tend to come as a package deal for InfiniBand, and OmniPath, which was sort of the alternative InfiniBand by Intel, got kicked out of Intel and became Cornelis Networks, and that's still a thing, and it's starting to resurge due to the NVIDIA purchasing Mellanox thing. There's some really interesting, like Rockport Networks is sort of interesting as a RDMA over converged Ethernet option, but has sort of scaling issues if you're getting into sort of the half exascale and higher. And then the really interesting thing actually is composable architectures and CXL. These are really interesting because you can rethink how you're building your HPC. So that you don't have to make every node super general purpose. You can get a whole bunch of things in one section and a whole other section and sort of virtualize the machines you need out of those things. And so it's really interesting. Storage, look, it's forever a problem for every reason. You can imagine, we'll talk a little more about this later, but the majority of organizations still are going for volume and cost over pure performance. We just got to get stuff done and you can't spend billions of dollars doing it. So cost is always a limiting factor. Buying petabytes of anything is still very expensive, no matter where you are, in the cloud or local. Without data value and data life cycles, understanding data value, which I have a slide for later, you have to sort of plan for infinite storage. storage. Cloud gets expensive at anything over a petabyte, so does in the data center. There's some really interesting, data management plays. Just the one that I'll mention here is Hammerspace. And there's a few other good products that are coming out to start helping with that. And still the most common life sciences on-prem HPC in our space is still GPFS or Spectrum Scale or whatever they call it now. I think IBM renamed it again. But Lustre is getting better. DDN has been improving it, but it still doesn't handle a lot of small files well, and life sciences still has that problem. Some of the next generation storage architectures, Fast and Weka and Pure, and some of the others are starting to really surge into the space. We're seeing it almost everywhere now, and people have been generally pretty happy with that. Networking, this is a whole thing. So I'm going to try to move through this pretty quickly, but everyone, you have to move your data. I don't care who says, let's bring the compute to the data, you're still going to have to move it, all right? At least once, probably a whole lot more. So let's remember that. Yes, let's move it as little as possible, but you still need networks to get things done, right? And so you have to back things up. There's a whole bunch of, and ultimately, if you're going to share your data according to the NIH data management and sharing policy, you're going to have to move it somewhere so that it can be shared. The reality, though, and this has been true as long as I've been at BioTeam and more, is that enterprise networks are still not designed for science, right? They're designed for, web and email, and for limiting the amount of risk to the organization as much as possible. And so they're built with multiple layers of aggregation, distribution layers, all these things that end up with hundreds of times oversubscribed equipment sort of at the borders to the internet. And so it gets really hard. They're not built for large scale data transfer in a lot of ways. Works fine for a lot of the small stuff, but the big stuff doesn't. So in science, still 10 years later, this is the most common high-speed network. People are shipping hard drives to each other. People are moving things around, and even on campuses, people are walking hard drives between each other because it still doesn't work. For a long time, the only way to really solve this without convincing your organization to redesign the network for science, which most organizations won't do, though some do, is this concept of a science DMZ or a perimeter network. And this was a concept developed by the Office of Science, ESNet at Department of Energy, to create a science-first network between all the national labs, so that data can flow more freely. And the idea is that it's a very fast, low-friction network with security policies built into the equipment that aren't traditional firewalls. And basically, there's a much narrower use case for these things. And so, from an attack surface standpoint, from a security perspective, you can sort of do, you can do a whole lot with this without having traditional firewalls in the way, and it's still going to be really safe. And it sits outside of the main network, right? The sort of enterprise that I showed before. So you can put things in here like, sequencers and HPC equipment and, layer it on and things like that. And it's still a really good option as long as IT sort of gets what it's for and doesn't decide it's super insecure and then lock it down even more, which we've seen. The latest buzz, actually, though I'm sure everyone anywhere near this has heard of zero trust and microsegmentation, right? Most people actually don't know what it is. It's a giant buzzword, but this actually is a real viable path towards re-architecting enterprise networks, because even Eli Dart, the guy who invented Science DMZ, says that that's a Band-Aid. It's not the right way to fix it. The right way to fix it is to fix the networks entirely and make them mission-based, not risk-based. And so what this type of a thing allows you to do is to just sort of default not trust things that are non-standard, like people's laptops and microscopes and Internet of Things sensors and sequencers, equipments, all those things. But allow a path through the network to identify them, identify the type of data coming through. So it's almost like application-aware routing in a lot of ways, and create fast paths through the network that don't need to go through firewalls. Log it so that security has it, but send it through a 100 gig path. Everything else can go through the 1 gig firewall, and that'll work. And you can do this dynamically, and it exists today. People are trying it. I wouldn't say that there's, it's hard. So, but it's promising actually. And the reality is that, you know, networking, it's basic for modern biomedical sciences. You're not going to get it done without it. And things are moving fast. You know, when I first started working with networks at BioTeam, you know, 100 gig was just sort of coming up. Now we're at 400 gig standard. There's 6 to 800 gig optical transport networks. You can actually switch light now, which is really cool. It makes things a lot easier in regional networks. 1 terabit networks are in early release. If any of you went to supercomputing, they demonstrated that, and a 2 terabit network. It's crazy, actually. So there's a lot you can do there. All right, so moving forward, I'm repeating this slide. The pandemic changed the game, right? All the things I said before are still true because I'm switching to cloud now, right? So what ended up happening is that, you know, all these resources were stressed, supply chain was crazy, and cloud, rightly so, launched a brilliant marketing campaign saying, hey, come here, we've got everything you need. And, you know, it's not untrue. But it convinced decision makers really to go all cloud. My general problem with humanity is that people tend to think in absolutes. It's either one thing or another, and nothing in between. The truth is that everything's a spectrum. Nothing is one way or another. And in decisions like this, you know, why would we ever do anything in a data center? Let's not do this. You know, abandon things that work well because this will be better. And reasons, everyone's doing it. It's cool, so people will invest in it and support it. And leadership likes to talk about it. And the reality is it's a really nuanced situation, and there aren't any absolutes. So what ended up happening is aggressive cloud migration programs were started. Most science organizations started planning cloud first or all cloud transitions away. And let me be clear, there are really good reasons to do this. I don't want to say it's not a good reason. You know, at some organizations, it's way better to be in the cloud, more flexible. It just depends on what you're doing. You know, cloud providers really gave deep discounts and a lot of direct support. You know, and people stopped planning for local architecture like HPC and storage and even networking, forgetting the fact that you actually have to connect to the cloud to use it, right? And all future planning for cloud-based architectures. And at BioTeam, we've seen this movie before. Let's go back to 2008 and to 2014, where we helped several organizations migrate their cloud to cloud and close their data centers. And AWS was really the only game in town at the time. And, you know, I think deep inside we were like, this is probably not a great idea, but let's do it anyway. And, you know, the draw is what it is today, you know, cheap, easier to manage, endless supply of compute power, less staff needed. It's better shareability. What the reality was at the time, which is slightly less so today, actually, is that the cost was 10 to 50x of operating data centers. And everyone was like, but it has to be cheaper. We don't need a data center, but that's not actually the way it worked. And cloud couldn't replace all the local infrastructure. You know, it requires specialized skill sets. It's harder to use. You know, I tell people, you know, the cloud is really, you know, access someone else's data center with a credit card and a weird access model, right? And that's pretty much what it is. And so the result, and, you know, using this guy's term, was cloud sobriety, sort of a massive pullback. And what short memories we had because it happened again. Right? Everything old is new again. For different reasons, you know, there are way more cloud providers. They're far more sophisticated. Clouds are largely able to handle most enterprise needs now and do it well, and that's a good use case. You know, and you know, competitions force huge innovation in cloud services. There's lots of differentiation, and the flexibility of cloud architectures, you know, combined with those supply chain issues, makes it really, really attractive. So, relevant questions: to cloud or not to cloud, right? In science, can you do real HPC in the cloud? Yes, now you can. Back then, you really couldn't. You had to sort of cobble it together, but now you really can. You know, and you know, I think that, you know, AWS has a lot of really interesting parts of this. Google just released a whole HPC architecture, and Azure's had, you know, like, you know, real Cray supercomputers on the floor for a while. And so you can do this. Can you create a secure environment? Sure, but it's yours to mess up. Right? You know, they're not going to sit there. You're using the cloud is automatically more secure. That's definitely not true. Can scientists use it out of the box? It's the most important question. Absolutely not. 100% no. It requires setup of services, user interfaces, platforms, even the sophisticated users who understand APIs, command lines, sysadmin, all those things need to architect their environments before they can really get going. There are some things out there that are out of the box, and it's getting better, like AWS Omics and DNA Nexus and a few other things that are really cloud-based that you can sort of get going on. But the reality is it's just a lot of services you got to string together. So science out of the box is really hard to do there. Can use it for storage, definitely, but it's really complex. It's even more complex in some ways than on premises. It's hard to price, real easy to overdo. And once your data is in the cloud, it costs money to get it out again. They sort of trap you in a lot of ways. So there's a lot of advantages to cloud. I'm going to sort of flip through this a little bit. I think everyone knows, but why not all cloud? There's sort of a fundamental mismatch between cloud business model and long-term research goals, right? These are private for-profit companies that sound like utilities, and we treat them like utilities, but they're not. They are private for-profit companies. We are a private for-profit company. Let me tell you that makes a big difference, right? They can offer services that they can change at any point, and they do. One of them does it more than others. The shortest full scientific study is like 5 to 10 years. Some are hundreds of years of data, right? Clouds don't even disclose the time period that they owe you to get your data back if they shut down or change a service, right? And everyone's like, oh, clouds are too big to fail. Nothing's too big to fail. I think we've seen examples of that, right? So if you have 50 petabytes of data in the cloud, what's it going to take for you to put 50 petabytes of storage on the floor somewhere in a data center and pull the data back? A year at least, and a whole lot of money. So this should concern you, right? Hybrid computing sort of preserves data ownership, and the source of truth can be kept locally, and you can do really nice hybrid solutions. Adam's going to talk a little bit more about this. We've been hearing about hybrid and bursting for a long time. Like 15 years, still not solved. It's something that we're trying to press forward on this year and make more of a reality, but it's still not solved. So I've got just a couple more slides here. So let's talk about data real quick. FAIR is another word we hear all the time. How are we doing so far? Not great. There are limited pockets of excellence. Why aren't we doing well? The short answer is people, not technology. We do have the technology to do this, but people are really the limiting factor for lots of good reasons and some really terrible reasons. One, it's really hard to do. It's extremely complex. There's tons of historical data. We have a total lack of unified data standards in our field. There's a ton of distraction, a lack of sophistication, a lack of tools and training, a lack of accessibility. And the biggest one, there's no incentive to make the effort, zero, right? All incentives are individual, say NIH grants or funding KPIs within pharma companies, R&Ds. This is a community effort, and unless the community is incentivized to do it, no one's going to do it. They have to get their science done. And so right now, it still pays to do your own thing. It pays to generate a whole new ontology or new metadata to do your thing, because people are like, oh, that's new, and get funded for it. So there's not a lot of clear vision leadership or directives from funding organizations to get there either, although it is getting better. And so this lack of unified data standards is a big problem, all the way out to electronic health record systems. There's a lot of stuff going on. There's a lot of pockets of excellence here, and there are data standards. There's just 38 of them, and everyone thinks they're the best, and so that doesn't help very much, right? There's a really big problem that historical data is really locked in publications. Each domain and project has its own format and standards. And on top of it, everyone's like, cool, let's build data platforms. That'll fix it, right? They're everywhere. There's everything you can imagine. Data lakes, oceans, fogs, swamps, islands, universe, warehouse, commons, ecosystem, mesh, fabric. There's more. And I think a new one gets invented every week. But bottom line is that while individually some of these things are, they're overused, but they're also useful, you're just building more silos of excellence because they don't interoperate. The I in FAIR doesn't really happen, right? It may work for a group of scientists or an organization, but beyond that, it doesn't work that well. So you really need a diversity of tools and approaches, but they're not cross-compatible. And then talking about data value real quick, this is something we don't understand in general in life sciences. What is the value of scientific data? There's two ways to look at it. Investment, how much money does it cost? There are companies that sell data, so they've monetized data, and that's probably the closest we've gotten, although they're not even sure how much they should be selling it for, to be honest, right? And how much did it cost to generate the data? What's the data worth to an organization that generated it? But then what's the scientific data value? Will this data ever be reused again? How long do we keep it? What's the impact of each unit of data? Is this something we should just automatically get rid of every time it's created? We don't know. And so we hoard it, all of it, and build infinite storage. And we say everything's high value because why wouldn't it be? And so, as much as I love you storage companies, it's good for you guys, but no one else really. So we can't prioritize investments in data, and they're not aligned with the strategy. So if you take all of this in totality, right, we've kind of transitioned from the information age, which was big data, remember that buzzword, and people still say it all the time, to an analytics age, right? We have to gain value from the collected data. AI really put a lot of pressure on the field innovating, and I'm not going to say a ton about this because the others are going to dig into this a lot more, but here's my AI slide, because no talk is complete without an AI slide. Let's be honest, it's super overhyped. Sounds a lot like big data, sounds a lot like other things. Most people really don't understand what AI machine learning is, and most people think it's this, okay? And it's not, right? General intelligence, we're really far away from. I know it seems like it, and Anna's gonna explain exactly how it seems like it, but it's not. And so every organization we talk to, I guess I should say, every organization we talk to says they have to be AI ready, and that's what they're talking about. But it's super overhyped. If you look at the Gartner hype cycle, from last year, which Anna's going to go through more, you see that the majority of things are on the innovation trigger or at the peak of inflated expectations. There's a few things that have fallen into the trough of disillusionment here, where people are like, "Oh, this is not going to work." Right? And things that are on the slope of enlightenment towards the plateau of productivity. She actually has a newer one that shows, the one thing that we thought would probably be here is chatbots, and that's where it is, right? And so the reality is that most things in life sciences are still at least 2 to 5 years in AI away from productivity. It's still very much a research space. Absolutely should be doing it. It's amazing, but AI is like any other viral subject. Everyone talks about it. Most don't really know how to do it. Everyone thinks everyone else is doing it, so everyone thinks they should do it. And so they put everything into it because they think they should. And the reality is that when you're talking about AI and ML, it's a very diverse field. This is a super oversimplification, but what most people think they're talking about is the very top there, deep learning, machine learning. All right, more is creeping in. Natural language processing is a big deal. Generative large language models are another one, and so it's diversifying. But up until about last year, all anyone was really talking about was deep learning, and there's a whole lot more to it. Okay, so here's the trends recovery slide, last slide. All right, so in summary, there's still a big push to the cloud. The cloud push is actually slowing down. On-premises planning is back because the supply chain problems are starting to relax. We've had the same data problems for the last 15 years, but they just got bigger and more complex. New silos have popped up that make a difference locally, but make it harder as a community to process things. And so what's the meta takeaway from all this? IT is disconnected from the science mission in general. And that's always been the problem, but I don't think I personally realized this until the last year, is that, they're doing IT because they like, shiny things that run in data centers. And, they like not working with people or whatever the driver is. But connecting that to the reason they're doing it at science organizations is really important. Science is disconnected from supporting infrastructure and not really incentivized to change, right? A lot of science, as I said, I think nearly 100% of all modern research needs advanced infrastructure to be able to do the work. And a lot of laboratory scientists don't know it, aren't trying to learn it, and utilize data scientists, which again is great for the data scientists and bioinformaticians, but it becomes a bottleneck to discovery. Data science is sort of caught in the middle, and being a bottleneck, as I said, and we're on the verge of making meaningful change because of and in spite of AI and ML, really. And so that's what I've got for you. Thanks for the fire hose. I'm going to turn it over to Adam for more fire hose, and we'll have a Q&A at the end of the session. So thank you.
All right, let's go. Thanks, Ari. All right, I'm Adam Kraut. All right, so these are some of the things I want to talk about. Really, it comes from sort of, things that we're hearing, talking to our clients, talking to people in the industry, talking to a bunch of folks this week. And it's things we're hearing from executives and leadership. And it really covers across these 3 important areas that every company needs to align across, which is, technology and technology trends. And we're going to talk about some of those common ones, processes and how organizations need to kind of adopt change management and how we think about things. And then also people, right? The people problem and how we want to lead in this space, which I think is a really important topic for all of us to think, because we're all sort of serving as some form of leadership in this bio IT space. All right, so how many people are familiar with Fear and Loathing in Las Vegas, either the book or the movie? Okay, you're going to see a few quotes. Yeah, otherwise these quotes are not going to hit. So anyways, So yeah, obviously we're at this really crazy inflection point in AI and machine learning, right? The pace of change is staggering. It seems like there's announcements and new things being released almost on a daily basis. It's on the nightly news now. Your grandmother and aunt is asking you about how to use ChatGPT. BioTeam's non-technical co-founder Stan is ChatGPTing all over the place and writing blog posts about how to be using ChatGPT effectively. So it's just the hype is absolutely ridiculous. It's a lot of hype, but I think it's interesting because it reminds me a lot of sort of the cloud era or the cloud revolution, which I was like a big part of. Like Ari said, it was 2008 to 14. I was completely cloud addicted. I was like, just everything had to be cloud. It was really exciting to me. But in the same way, I think, the hype is there, but it's because people see the value in this, right? And I think I would say that all of our clients are really seeing value in the potential of AI. That's pretty obvious. But like cloud, that was, a 15-year journey. And so I think we're just at the beginning of this AI journey, and it's just kind of hitting now this inflection point. And all of our clients are saying, we need more AI ML. And in the same way with cloud, I think people saw cloud as a way out of the sort of capacity planning problem and as a way to kind of, hey, it's unlimited compute, it's unlimited storage. But that came at a real cost. And in the same way, I think people are looking at AI as a way out of their data problems, right? As like a shortcut. And again, I remember when cloud was hitting the peak hype, everybody was talking about private cloud or how they were going to become the next cloud service provider. And in the same way, I would say just because you have data doesn't mean you're going to become an AI company. So think about the costs of that and think about how you're really not going to be necessarily a leader in the AI revolution. You're really just merely a participant, and that's okay, right? So you're not leading the conversation, but you're a part of the conversation. So really just think about that when you're thinking about AI, because I don't think we're all going to be leadership, and that's going to be fine. So again, what we see companies doing and clients doing in this space, I have to give credit to Fernanda from Voltron for this idea, but I would call these kind of losing strategies if you're a company approaching this AI space. First of all, people are buying up AI startups left and right. I mean, for whatever price, and so that just seems like a really bad strategy. Completely ignoring ethics and bias in their data. Again, a bad strategy. I don't think that's a good idea. You really want to think about ethics. Anna has a lot more to say on that. Just adding complexity to processes, right? Just for the sake of complexity. I mean, let's remember the principle of simplicity, and simple plans are effective and easier to execute. So don't start making everything complicated because you want to wedge AI into everything. Starting with all your sort of petabytes of historical data and thinking that AI is magically going to start doing something with that, I just don't think that's a good strategy. You really need to think about the type of data and focus on these more narrow problems. Again, deploying AI right into customer-facing things. I mean, chatbot's an obvious one, but now everybody's putting things right out into customers' hands. I don't know if that's the best way to go about it. Trying to sort of like reinvent the wheel and build your own foundation models or playing around with model architectures. I think that stuff's mostly solved for most of us. So we can just kind of consume what the ecosystem is putting out. We don't have to reinvent the wheel there. Just trying to solve general and broad problems, I think, is a mistake. I mean, I think obviously the power of AI is in sort of focusing on narrow problems and narrow AI and not the general AI, AGI that Ari referred to. So again, solve really focused and narrow problems for your people, right? And then this idea of like outsourcing everything, right? We see companies that are heavily outsourced. I'm talking 80% outsourced in their IT and technology. And I think that's, again, losing strategy. Outsourcing competency isn't a good idea. And Anna has a lot more to say about that as well. So what are some winning strategies that I think in this space? Again, credit to Fernanda for a lot of these, but again, hiring more data curators and people that really understand your data at a deep level. Thinking about, building data, like tagging and data enrichment and metadata enrichment into your existing processes, right? You don't have to reinvent all your processes to start benefiting from some of these advances. Building data platforms is good. I have more to say about it, but things like data lakes and trying to build data commons, there are good aspects of that. And I think it's a general good thing to start on. Really just, again, solving your own problems is always a winning strategy. So look within and sort of find small problems within your organization that you can try to solve with AI first. Finding ways to share data and build data partnerships is going to be really important. This is obviously happening a lot in pharma, but data partnerships and who's involved in those conversations, and are you bringing in ethicists? Are you bringing in people who are really looking at the data in a way that they're going to control for bias and they're going to control for a lot of these things is going to be really important. And again, reusing these great model architectures we have, transformer architectures change the game. So let's use those. Let's use the stuff from stability and just not reinvent the wheel. That's not where the people in this space need to be innovating, right? We have bigger problems to solve. So let's use the state of the art to solve our own problems. And again, focusing on really narrow problems, I think, is a way to win in this space. And insourcing, we're seeing a big trend around insourcing. Again, that outsourcing trend, I think, is being pulled back because these are capabilities you need to bring in-house. You have to train your people. You have to train your internal teams to use this stuff. Don't just look for some hot AI startup and buy them and think that that's going to sort of bring all your competency in-house. It's not. All right, so data platforms are still a big deal, and people are thinking about unified data architectures and data, right? We're going to say data 1,000 times, but we don't lack in these data environments. When we talk to clients, they're like, we have tons of data environments, dozens of data environments, right? But we really didn't put the foresight into solving that sort of interoperability or integration piece. So interoperability is a huge issue as we stand up data silo after data silo. So thinking ahead about how these things are going to interoperate, how they're going to work together is key. And how are you going to drive yourself as an insights organization? It's not just about building another data lake. And I think for data, you really want things to come together. Like you need the context around the data. You need well-connected data, right? And that's really missing the connectedness and also the collaboration around data. And so I think like our ability to generate insights is going to be rate limited, not by CPU power or Moore's law, but by the connectedness of our data. The more connected the data is, the better it's going to be applied in sort of AI ML contexts. And so again, if it's accelerating science, we have to sort of build foundational capabilities, build digital backbones, build sort of data backbones that can sort of serve lots of uses. And that's why platform building is still relevant and fair data is still, an unsolved problem and a journey that we're all still on. All right, so what does a healthy data ecosystem look like? Or if I'm looking at examples of good data platforms, discoverability, the whole findability problem is still an open problem. I mean, there are companies with dozens of S3 buckets and you just can't find anything, right? So you still have to solve that findability piece, and surprisingly, it's not solved. Having sort of good data integrity when data is created, right? And you'll see sort of more and more companies are thinking at the experimental design step, what kind of data are we going to capture? What's the shape of that data? How are we going to sort of make that ready for downstream modeling? And again, if you think about that, when the data is instantiated or created, I think you're in a better place. We hear things like data citizenship and data stewardship from companies like Roche. And I think that's really a good thing because it's starting to foster a sense of community and ownership around data. So these new roles of data steward, data curator, these are going to be important. So keep hiring for these, keep building these capabilities in-house. Data is chaotic. So anything you can do for sort of standardization and developing common languages, I'll talk about data dictionaries, that's going to be really important to sort of master your data and control your own data is common languages. We have to be speaking the same language. And then using automation as leverage. Obviously, automation has a lot of hype, but I do think like pipelines as code, infrastructure as code, sort of iterating fast is going to be great if you have the automation that can support it. All right, so data dictionaries are still really important. And actually, it's like, there's a lot of value in these. And I think it gets overlooked when people are sort of setting up data commons and other systems. The data dictionary part is the piece that you care about the most, right? It should be the piece you care about the most. And because it's like fundamentally a data management problem, everyone wants to kind of punt on this or ignore this part of the problem. And as you know, we have sort of storage all over the place, right? Data generating instruments are writing to a bunch of different storage. So having some discipline around your data management is key to sort of the freedom that you want with data. And I think like, again, just discipline equals freedom. I think that concept when it applied to data management really makes a lot of sense to me. And like Ari said, 80%, or maybe you didn't say this, but a lot of effort in data science is just organizing data, moving it around, preparing it. That's not necessarily a bad thing, right? That is kind of what data science and data engineering is going to be. So don't avoid that pain, just do it, right? And just kind of embrace that pain. I think we need to do it. And it's kind of like getting in shape. It's like getting your data in shape, right? You just kind of have to do it. So data sourcing, cleaning, harmonizing, that's all sort of stuff that we shouldn't necessarily think is a bad thing. I think we should, again, embrace it. All right, so data ecosystems is kind of, again, it's all of the infrastructure, it's all the people, it's sort of your entire data landscape, right? But sometimes I think we don't think about the economics of our data. And like I already talked about, sort of what's the value of our data? And there are some strategies from other industries that you can use for sort of data monetization. And you may not be in the business of selling your data, but having the conversations around what is our data worth and how are we thinking about the value of it is important. And so there are a few data monetization strategies you can find from other industries. There's the improving strategy, which focuses around sort of cost optimization, finding process efficiencies, leveraging economies of scale. Then there's wrapping strategies where you can sort of add digital companions to your data. You'll see that, also digital twins. And then there's companies that are just trying to outright sell data or broker data. So those are three strategies of data monetization But ultimately, I think what we need is like a scientific data value framework, or at least we need to start talking about it. And how do we kind of think about the mental model of scientific data? And I think data, scientific data in particular has like an intrinsic and an extrinsic value. Like the intrinsic value is like, what did it cost to produce that data? What does it cost to store it? But the extrinsic value is what is it worth to a predictive model? Or what are the capabilities of its reuse? That's kind of the other part of the value that I don't think we have a good equation for that yet. So I'd love us to just keep thinking about that. One lens to really think about data value through, I think, is just use cases, right? Find really powerful use cases that solve problems for people. When you sort of find someone's struggle points or find what they're struggling with, the people that are closest to the data, and solve something for them, make their life easier, you're now demonstrating value. And then you can start to get to that sort of value statement. I want these use cases, though, to be rooted in business outcomes. It's not good enough just to talk about the data itself. Let's think about how data science and using that data will drive our company decisions. And those company decisions are things like, what targets should we be thinking about? What's the next experiment? What kind of indications are we going after? Who should we hire? Who should we acquire? What's our go-to-market strategy? All of that is like company deliverables that I want your use cases to be aligned with. Otherwise, you're in this weird space of just kind of talking too much about data and use cases that aren't driving the business forward. And again, all this kind of has to come from a place of communicating with the scientist in their language, right? So again, it's common languages and building those relationships with science. So again, you'll hear sort of a common quote that, some companies look at data as exhaust, but we look at it as fuel. That's something I think Recursion said. And I think that's a good way to think about it. It is a bit of a mindset shift that data is not just kind of a byproduct of what we do, but it's sort of fundamental to what we do. And again, let's think about that as sort of shifting the mindset. And I think it's important for leadership to really be involved in these conversations, walking the production room floor, so to speak, to really know what's important to people and create that sort of shared vision for how they want to drive change. It's just change management, essentially. All right, so cloud. I think cloud capabilities, we're still talking about cloud 15 years later. And we still believe at BioTeam that science changes faster than IT. And so cloud is still here to stay. And I think HPC and using cloud-based HPC is more relevant than ever. If you think about the need to generate and simulate a lot of data to train these models, people need HPC to do that. People need fast compute. They need broad scientific computing capabilities. And a lot of the conversations we're having now are still about what are people doing with their IT infrastructures? How are we going to refresh this? We have 3 to 4 clusters that are traditional HPC clusters, but maybe we should be buying an NVIDIA supercomputer as the next cluster. And how are we going to transition to that? How are we going to move our workloads? We want to lean into AI ML, but what does that mean for our infrastructure? What does that mean for sort of buying versus building? So people are still asking these questions, and there's a lot, this is hard for larger organizations because they do have a lot of relationships built up. There's a lot of sort of turf protecting, there's technical debt, there's limitations on their facilities. They're seeing moves, from cloud and back, like Ari said, colo facilities are sort of seeing a resurgence. So in my mind, there's like these perpetual cloud migrations that have been going on for over a decade. And then people are kind of thrashing back and forth. Chris Dwan, our friends, talks about the seasons of a digital transformation. I think that really resonates with me because they go through this growth and then pullback and then it's cost, then it's capability. So I think this is just life, right? And how we're going to have to think about scientific compute, storage, and these ML platforms as they sort of come to bear for us. All right, so again, I was a cloud addict for a long time, still maybe recovering, I don't know. But so hybrid cloud is a strategy that we pitch. And I think it's confusing to people because when we say hybrid cloud, they kind of hear cloud bursting. And multiple times, even in this year, I'm hearing clients come to us say, we just want seamless cloud bursting. I've got my Slurm HPC cluster. I just want some cloud nodes to sort of appear when the queue is full. And then I want those jobs to run on those cloud nodes, but I don't want to have to deal with identity management. I don't want to have to move my data. I don't want to recompile anything. I want all of my environment modules. It should be seamless, right? That doesn't work. It just doesn't work. You can't do that. And I wouldn't recommend it either. And why? I think Ari touched on most of that. It's that our networks really aren't designed for it. So, you're going to either have 2 copies of your data, or you're going to be moving data in weird ways, or paying a lot of money to send data to Amazon or whatever through a caching system. The storage IO is never quite right. If you're running local storage, remote compute, your IO is going to be terrible. The other way around, it's still terrible. Software management is hard in that situation, right? You've got big application trees. You can't just sort of snapshot those over. Anyways, there's a lot of like little details that make the whole promise of cloud bursting, just not a reality, and it just doesn't work. So still think about cloud as that capability play and not a way to just sort of get out of your capacity planning problems or your resource management problems. All right, again, I think it's really important to sort of have domain experts and build these cross-disciplinary teams. That's, I have a few more slides on this, but really, they are your domain experts are your end users. And I think we're often too much thinking about the supply side or the solution side of things and not about the demand side or the sort of problem side, right? So I heard this yesterday or 2 days ago from Recursion. They said, users are typically the experts in their problems and builders are the experts in the solution space. So discover the problems from the users and the solutions from the builders. And this is kind of like a stay in your lane thing. I think we all want to think that we're experts in things that we're not. So keep experts, in their lane and in their domain, and focus on people's real life struggles. So that's what I would say. And this is, again, a different sort of mashup of skills that we're not really used to kind of combining. So I think this is always interesting to me on how you might build teams that can operate well in this space. So again, on this sort of cross-disciplinary space, I think a trend we're often seeing is around sort of, you hear project to product, right? Everyone wants to shift from project mindset to product mindset. This is an interesting trend, I think. I think it's really rooted in sort of trying to solve business problems. You might even call this just good business analysis. But really, business problems are sort of the foundation to your digital problems. And this involves like really thinking about, again, value stream mapping, business process mapping. It's really plugging into the business in a new way that's a little bit deeper. And it does come at a cost, though, because you might think that everything now has to become a data product. Every spreadsheet now just becomes a data product. Like, that's not scalable, right? That sounds like it's a lot of bureaucracy. It sounds like we're going to have sort of change management everywhere. So think about where you are in the sort of product tier, because if it's a prototype product, fine. If you're considering it sort of a premier product or sort of your high-end product, then that's gonna come with a lot of cost, I guess. So just really think about that. And again, just thinking about how we sort of deliver data as a product, data packages. This is all sort of things that we're hearing from folks that are leading in this space, and it's interesting. And so product mindset maybe combined with good domain experts is a way to kind of work through this space, thinking of data as a product. I still like DevOps. People aren't really talking about it anymore, but I think it was really important, like philosophy that we seem to have forgotten, or I don't know. I think it's still relevant, and you can just kind of keep changing the front of that. So from DevOps, we go to data ops, we go to ML ops, we have AI ops. All of it is really about sort of bringing technology, people, and process together. So where will you see AI ops show up now in this new age? I think it's going to be in things like, again, data set versioning, how you're doing model development, how are you executing your training runs. But really I think it's going to pay off most in that sort of continuous fine tuning of ML and AI and the sort of continuous data integration. It doesn't just sort of end when you have, a model and can do inference. It's continuous fine tuning and integrating your data as it's continuously generated, right? I don't see enough of that sort of follow through. And I think that's where AI ops, if it's a thing, that's going to really help us. It's going to help us with data quality control. It's going to help us if we have tools for identifying, bias and ethical consequences. Really, it's just software development best practices, but I think applied in this space is going to really pay off. And it helps us sort of abstract away infrastructure, which is something Ari talks about. Infrastructure should be abstracted away from science, and that can also be done by platforms. All right, another thing I keep hearing all the time is this like need for speed, this like hunger for speed. Every company has like light speed or quantum leap or some new way that they're going to go like so fast that you can't believe it, right? And it's all, ultimately it's great, right? I mean, BioTeam believes in accelerating science, and for pharmaceutical companies, this is about reducing cycle time and, getting drugs to market faster, et cetera, et cetera. So speed is the characteristic that everybody wants. And so I see organizations trying to use this two-speed architecture, right? Where like some science kind of moves slow, but really there has to be this mode where we go really fast, right? I would say COVID or the pandemic kind of caused this thinking or shift in thinking. And let's consider this and be careful with this, because, just moving fast is interesting, but if you don't know exactly where you're going, merely moving faster is not going to get you anywhere. And so, sometimes slow is the way to go, or slow is smooth and smooth is fast. So like, let's just not always go for speed, but think about it. And, power to weight ratio and the things that we build should, again, be light and agile. And that way speed isn't such a killer when you're light and agile, right? All right, so again, I always like to talk about sort of like leadership and upskilling and how do we like improve our skills. I think this is really important for people to, how do we keep our staff, our people sort of trained and on the cutting edge. And I think it's just by sort of ongoing, consistent training together. So like cooperative learning, Bio Team likes to do a lot of hackathons and data jams and ways that we can sort of work together and learn together. And I've heard this from Regeneron. They like to pair, it's kind of like pair programming, but they're actually putting the data scientist and the medicinal chemist next to each other, working together on the same set of tasks together. And traditionally that wouldn't be the case. Like the medicinal chemist would have the last call on a decision, but now they have to kind of work side by side with the data scientist. I think that's just a really interesting way to approach this space. And it reminds me of sort of, in martial arts where we have training partners, like you need a training partner to get better. And maybe if we're sort of pairing up in these new ways across domains and across disciplines, that's a better way to train. And then it's all about just creating the training environment, right? And there's lots of ways of doing that. You can do hackathons, or even, I was a big fan of like chaos engineering, put people through tests of failures and see how they deal with failures. I think that's a really cool way to upskill us. And there's a term in jiu-jitsu that I like. It's called keep it playful, and it just means like things shouldn't be so hard that you're stressed out, but they shouldn't be so easy that you're bored. And so I think if the more we can kind of create that sense of flow, well, that's the way we optimally learn. And so these trends that we're hearing are like more insourcing, right? Like we're a consulting company, but stop hiring so many consultants. Train your people and insource your skills, because these are really powerful skills, right? Cross-disciplinary knowledge. I mean, problem solving is the ultimate skill set. So how are you going to build that into your team? Collaboration, adaptability, innovation, those are all like very desirable skills. So how do you kind of build these cross-disciplinary teams with range, right? Imagine the range these teams have to have. You need all the stuff Ari talked about in the infrastructure, network, storage, security. You have to have all that, but then you also have to have biology, chemistry, data science, software engineering. That's a pretty, wide range of skills. And again, a mashup of skills that, not a lot of people have in one person. So it's really going to take unique leadership and thinking about how we structure these teams so that they can really perform in this space. All right, so my favorite, I always bring this up when I think high performance teams, but it's, it's the Navy SEALs analogy, right? If you're not familiar, World War I, Army and Marines were having a horrible time getting onto beaches, right? And getting onto land. And so they asked the Navy to like figure this out, right? So the Navy sort of had to come out of the water, and I'm not a Navy SEAL, by the way. They came out of the water. And so they built these like really interesting teams that would bridge the gap, for the Army and Marines, right? But so they had to kind of come up with this like new unconventional style of warfare, right? Which I think like this is a very unconventional IT space, right? I think we do things differently in bio IT, and we should respect that. And so we kind of need these like special IT operations. To me, that's what we're doing in bio IT, is sort of special operations. And for that, we need sort of T-shaped engineers and people who can go broad and deep to do that. So I think it just takes a special type of team. And I think there are models for building these teams. Again, I like the SEAL model, and I really like forcing the analogy. So Ari was like, data lakes, data oceans. And so it's like, okay, so data is the water, right? Data is swamps, data is wet. And, but the air, okay, so then the air would be like infrastructure, because, you need it. You need air to breathe and be alive, and good infrastructure should be invisible, right, Ari? And then science is the land, right? And so that's where, the territory, the terrain, that's where we're discovering. Anyways, bad analogy, but I think like we do know ways that we can sort of build these teams. And I think they're small teams, right? And they don't, again, they don't make excuses. They have sort of a winning mentality. They have to be diverse, right? If you're going to cover all those areas. They have to be sort of very resilient and have nerves of steel. I think if you're going to work in this space in IT, like it's because you care so much about the science, like it's solved for your why. And so that's what gives you that sort of perseverance to be on this type of team. And again, so that was all a little too masculine, I think, or hyper masculine. So I do want to say that like for this space, I actually think we need to balance masculine and feminine leadership qualities, because all this sort of masculine domination stuff, I think could do better with more sort of a sense of understanding and compassion and sort of these types of forces in leaders, not just sort of the pure sort of Navy SEAL masculine stuff I just talked about. So at Bio Team, we talk a lot about sort of, developing EQ, right? And I think like more cognitive empathy and perspective taking, putting yourself in other people's shoes is like the best way to be in this space. And I think as soon as you do that, you come from a better place where like my success is your success. And it's, it's not going to be just survival of the fittest. So, all right, that's all I got. Thanks.
So my manager would die if he thought I was here talking about EQ because we've had many discussions this year, even though, see, Ari's laughing. Even though, so I guess the thing you have to know is when you get bio team together, I know we're talking about very serious topics, but we can have a lot of fun. So as Kraut was sort of walking me through the slides, he had his previous slide, right? And he said survival of the nurtured. And I told him, I was like, well, do you actually know anything about female goddesses? Do you know anything about Kali? She essentially ate men alive, right? So I guess this is a nice concept, except to say that women don't just bring warmth to your organization, which is not at all the topic. Thank you. Exactly. Which is not the topic of my presentation, but all to say that I guess we can talk on a lot of different ranges. And the power of birth and death are equally important. And I just have to say within our organizations and our clients, things do have to die away sometimes, which is unfortunate, but it's true and it's part of the rebirth cycle. And so also part of something that I think a different perspective brings in versus just sort of like the do it fast, drive forward, get to wherever we're going. And the other interesting aspect, I guess I just wanted to touch topic on a few things that Adam said. The other thing he said that I think is really interesting is this concept of going fast, right? And one of the things I'll talk about with my sort of overarching concept of Fear and Loathing Las Vegas, if anyone hasn't seen it, you should watch it. It's really applicable to the way we're feeling right now in the AI space, is the idea of going somewhere not just fast, but also afraid, right? So we are all sort of very scared and trying to go somewhere very fast, which is essentially just the title of a National Geographic show, I think, and not the way an organization should actually run. But it does feel like we are in this very weird sort of delusional space right now with AI ML. And our marketing department, before we came here, sort of gave me a little heads up and said, why don't you just say a little bit about generative AI, right? Which of course is not that simple. And also I've been panicking for 4 days about what I'm supposed to tell you about generative AI because I take our marketing department very seriously. But I do think that it's important that we look at essentially where we thought we were going to be. I, in my life, have posted these graphs multiple times. I have actually never sat down to read one, but I actually want us to sit down and read it right now, because what we will see is that in 2021, we had all of these technologies actually earmarked for the next 2 years. So we have generative AI up there, and if it's too small, I don't know, you guys can go look later. But we had generative AI, we had foundational models, we had NLP, we had, what else did we have on here? Well, actually, interestingly, last year we had chatbots and transformers, chatbots being in the trough of disillusionment. And this year we decided that apparently they made it out. And I guess all to say that this revolution feels like it just landed upon us, but it didn't. We've known about it. It's just that as a society, we are super bad at understanding how this is actually going to land, right? So we know it's coming, but we have no idea what's going to happen when it gets here. And I guess not to make it feel doomsday like it's here, but we are sort of in the midst of actually interacting as the public with these technologies. So I think that's really interesting. And so another reference to fear and loathing is, I guess, my goal for, here, can you give me my water? My goal for this talk was actually to get us through some general understanding of consensus and where we're actually going to be, and to keep it sort of like, to get us here together, I guess. The idea of like, this is my nerves kicking in. The idea of actually like arriving somewhere as a group, because I do think consensus is really important. And I think that we can build consensus together if we talk about these things and actually understand like, where is the use for this technology, or as leaders, what should we be doing, or teams, what should we be doing? And so the discussion today is really going to be about mindset, it's going to be about capabilities, and it's going to be about LLMs and organizational to-dos. Okay. So the main point I want to make is that the era of optics is over. And the era of discernment and actual capability is actually here. What does this actually mean? It means that for a lot of teams and a lot of people, just being able to talk about this stuff was enough to actually be successful previously. I don't know if anyone else feels this way or has seen this in publications. I would say that's even true maybe for someone like myself who essentially worked tangentially with organizations, and I never considered myself to be, let's say, I'm certainly not an AI engineer, right? Which makes it sort of difficult to feel like an expert in the field. But I also think it's a feeling that a lot of, well, I guess I would say women, not just women, but people who are not typically part of the conversation have. But then what I have to say is, I came to this conference and we were also at an AWS event sort of a few days before. And I heard what experts have to say on the field. And I was like, you know what? I am qualified. And it is important to be part of the conversation. I guess that's a really important concept for your AI teams, is to sort of bring in that diversity, even from people who feel tangential. But I do want to stick to Adam's point of, you don't want them to necessarily feel like they have to become experts, but you do want them to be of service to the discussion. So I don't know, has anyone ever listened to Wayne Dyer? He's sort of one of the beginning gurus for self-development, I guess. And one of his tenets is always, if you're confused, if you're in a confusing situation, always focus on being of service. And I guess that's sort of my goal here, is to help be of service in some way and not to position myself as an expert. One of my colleagues, Jordan, always says that in these times, it's better to say less because you don't want to sort of mislead people as the expert. The problem being, as my team knows, I have a problem with saying less. In fact, Adam, my favorite compliment is that I am a chatbot. And so Adam says, if you just put me somewhere, I can just generate information. And so I guess all to say, take what I say with sort of with some discernment, which is going to be what's necessary. So again, if we continue with this idea of performance, AI is going to get us in trouble, right? Because the whole concept is it's generating things that may or may not have factual value. So what do we actually need to have competence or discernment? And this is actually something that a lot of teams said. So when AWS was showing their new LLM tools, they also said that you have to know how to solve the right problem the right way, whether or not with a chatbot or a generative model or a transformer or a pre-trained model, whatever it is, right? And if you have teams that cannot discern, that is going to be a huge liability, really in any scenario, but especially in this one. And there is a whole concept of fear, as I mentioned, and there are a lot of people who are sort of very nervous societally because this is the first time we're sort of talking about these things as a society, right? And so there is a small percentage of people who are really like AI doomsdayers, let's say, right? And I would say ignore those people. I hope I'm right.
I agree.
Yeah. But most people, and I sort of took a survey of talking to folks around here, and I think, we have a lot of bio team friends, and I've had the opportunity to talk to them. And I do feel like I have consensus here in the terms of most people are actually concerned about real life implications, which is like mental health, right? Things that we've seen from social media. So mental health, misinformation, potential harms to society, trust, those are all actual real concerns. I guess my perspective is that we have no actual ability to adequately predict how to manage those things yet. But I guess what I would have to say is that we can't put a stop to knowledge because we need new ideas, right? So we know these things are coming, and we actually need to generate more ideas about how to handle those concepts. So all of this talk of like pausing things, to me, is really inappropriate in terms of pausing knowledge. But I think if we talk about products, the government has a very real job. And in fact, our organizations, our legal teams have a very real job in controlling products, right? But we have to be very specific about what is product and what is knowledge and or research. And so mindset summary, performative tactics are going to fail, especially around this space. I know that everybody wants to position themselves as a leader, but you have to really invest into that. Robustification is going to outperform fear. And I think the question of who can I turn to and who can I actually trust is going to be the main question of the next decade, especially as these models become, oh, okay, sorry, the screen went blank. As these models become more and more complex. Okay, so now we're going to understand GPT a little bit. And can somebody tell me if any actual AI engineers are in the room before I start talking and embarrassing myself? And okay, thank you. Excellent. Excellent. Okay, so from my perspective, the number one point, I guess no one's ever going to remember everything we say, but the one thing I do want us to remember, and there's whole books written on this, is that society does a terrible job conflating factuality and statistics, right? And so these models, am I right? Yeah. So these models are statistical models at their basis. Yes, they're machine learning, they're algorithms, they're neural nets, but they're essentially giving you statistical probabilities to words, which is why sometimes there's so little factuality when we're asking for science content, right? So I think we imagine that we would start asking it scientific questions and getting factual results, which is not the case. So even though they're like sort of trying to give you a consensus word placed next concept, they're also introducing a little bit of creativity. So I put in a little example, which I think is actually quite useful to understand. So this is actually not my example. It's a whole, it's somebody who's an expert. Anyway, so let's take GPT-2, which is an older model, and then we ask it a simple question of, we want to finish the sentence, the best thing about AI is the ability to, and then we just wanted to rank from its understanding of language, sort of like probability-wise, what word should come next, which is essentially what these models are doing. So if you always wanted to output the best answer, it's always going to say learn, as an example. And if we keep doing this repetitively, word after word, it's going to copy human text, but it's going to come up with something that is essentially boring. Because it's giving us something that doesn't have any sort of like zhuzh to it, right? So we've actually figured out a way to program and zhuzh, which is the thing that people think makes ChatGPT human or have emergent properties, but it's actually just programmed in to make sure that it doesn't just always give you the next best statistical answer, but it can give you an output of a number of answers that are slightly less statistically probable, but are perhaps a little bit more interesting. Am I on the right track? Excellent. Okay, so then this is the thing that generates essentially the flavor that sounds like humans, right? Because it's interesting, it adds in interest. And then we start producing sentences, right? So we have these words that go one after the other and we produce sentences. But then trying to model sentences becomes too complex of a computational task because we can't capture all of human sentences and then learn from them. So this is where large language models essentially start to make combinations, word combinations and probabilities, and where neural nets start giving us opportunities of how to jump from node to make interesting combinations in spaces and in spheres. And grouping similar concepts together. And these little nodes are the things that we want explainability from. So we've all heard that we should make AI models explainable, right? So the one thing that I did see at the AWS conference is their desire to make models explainable. And the way that they did that is by actually trying to highlight the connection that each node in the neural net made in order to give you that answer. So I guess in our imagination, we would say, what are some interesting ways to cure cancer, right? And so the model would output a response and we would say, how did you come up with that conclusion? And it would give us like a point-by-point summary of how it got to that conclusion. So that is not going to happen yet. But it is a topic worth researching. And the reason it's not going to happen is because the way that these machines or models or nets actually make these conclusions is not the same, like, it is like our brain, but it's not like our brain. So let's take an image of a cat. So this would be the first node a picture of a cat outputs, right? This would make sense to us. We could see, oh, okay, it's taking some general outlines or parameters of what a cat is. That makes sense, right? So this would be node 1. This right here would be node 10. this is sort of an analogy, ball to say that take this in the context of scientific information. By node 10, you already have no idea what it's picking out, right? Or why it's making its conclusion, at least in the way that we have explainability structured today. So while we are driving towards explainability, please don't think that it is as simple as essentially outputting a reference list or something like that. Okay. So explainability is being tackled and it should continue, but it's not the answer. And to also say that we actually don't have a very good way to explain this as a narrative that humans can understand. But you can train models on data and they can sort of give you a way to generalize from examples. And we shouldn't sort of stop using the technology, but we should also understand its limitations. And the other two big things that I want to say, and I hope I'm saying them correctly, is that these models do not become like corpuses of all your scientific data. They are not data storages that are going to then query and output your scientific data to you. They are not query engines like Google. They can discover novel relationships through their nodes, but this is still a form of explorative sort of research, and we shouldn't use them that way. But we try to, and I'm actually going to skip, I'll go back. And we try to with, for example, genomics data, right? So we ask it things like, can you at least, make a reference from a gene symbol to a gene? And the fact is, it can't. It can output very random things to you. It can generate random genes, assign them to random disease, and give you random explanations. But there are groups that are actually trying to understand how to score these models for scientific information. And if you look, you can see that there's sort of different things you can score on, especially if your internal teams are thinking of training it on internal data. Make sure you have rubrices that are going to actually help you understand if you're getting nonsense out. Make sure I'm not cussing. So the first thing is, does it even understand its question, right? And can it tell you if it can't answer this question? One of the interesting things at the very bottom here, this is kind of a shame that I can't see the screen, is that at the bottom, when you ask it to do sequence alignment, it generally says, I'm an AI model. Like, sort of like, come on. And so that's really great, but most of the time it won't say that, right? Because most of the time it is just generating tokens or words or parts of words to answer your question, and it doesn't know that it's giving you nonsense. And if we can see from this ranking, even models that are sort of like BioGPT that are really trained on biological data are still not going to give you factual information. And so you have to be really careful. Okay, but what can it do? And so I love that Adam said that we're ChatGPTing all over the place, and it's true. You can ChatGPT all over the place. It has useful characteristics. As someone who, for example, is not a native speaker, I love the concept of writing with my colleagues and then having it, for example, harmonize our text, right? It can make it sound really, really smart, especially if you as the expert are checking to see whether or not the information is still correct. And please check with your legal departments to see if that's legal. Okay, but you do have to prompt engineer it. You have to do certain things to make sure that it sort of like rewords your text in the correct ways. But I think a lot of us are very capable of Googling prompt engineering for text and actually getting something useful. So that's fine. But if you start asking it for references, scientific articles, or assuming factuality, that's where you're actually really in trouble. What else can you do? So you can create your own interfaces to your own structured data. And I think that this is actually really probable. And I say that based on actual conversations I've had and actual functionality that I've been able to see from the demos in the halls, and also sort of from some of the new launches that came out this week. So you can train it on your own data, structured and unstructured data. From the unstructured perspective, I think EHR data, images, complicated data, like for example, voice, those are actually going to be really, really good. And the models actually are here. Bill, for example, loves the fact the Copilot feature on GitHub. I don't know how many of you guys have had a chance to try it out. It can really help bioinformatics workflows, especially if the person who's doing it knows what they're talking about. LangChain and other frameworks are actually going to be also very, very useful. And these are things I would actually be excited to help clients work on. They're things that I don't consider to be sort of unrealistic hype anymore. But my guess is that getting your team to run these LLMs is not going to be a challenge, right? So I actually feel confident saying if anybody said, hey, bio team, can you help us get a model, one of these models running on our infrastructure? I would say, yes, we can. And so running it on your infrastructure is not going to be a challenge. The challenge is going to be getting a quality output and knowing if you have a quality output from those models. And then, as Fernanda also mentioned, maintaining those models, sort of having the correct benchmarks and standards to evaluate your outputs, and actually thinking about what are we trying to get, right? So just like Kraut said, cloud wasn't the solution to storage, just like these models are not going to be the solution to poor data and or your lack of understanding of your own quality. And also there's actually a few things that I think are really important for us to think about in a social context around these models. One is that people keep saying that ChatGPT is democratizing AI, and this is garbage, right? So first of all, people apparently don't understand that there's a world outside of our, United States, for example, and what it means to actually democratize concepts. What I do have to say is that this is the first time people have gotten a chance perhaps to interact with some of these models if they have the infrastructure, compute, power, Wi-Fi, language skills, right? But this is not democratization. And the other two things are sort of based on that. And that is that English is going to be the next programming language of 2023. I think this is very, very egocentric. And this assumes that this is some sort of benefit to society. And I would argue that it's not. And then the second concept is that we think that just because these models sound good, they're intelligent. And our American concept of conflating fluency and intelligence, I think just has to go out the window, right? So I think this is absolutely ridiculous. My dad is a Soviet scientist, and he used to get so angry when he would go to Lowe's and people wouldn't understand what he was saying and would sort of assume that he didn't know what he was saying. And I think if we keep reinforcing that concept that just because it sounds nice, it's intelligent, is going to cause a lot of problems. So as an organization, the first thing I want to say is that organizations are going to have to choose whether or not they want to look good or be effective. And those two things are going to take slightly different paths. And I guess I want to reiterate the concept of coming from this place of service and competence and not novelty. If you just want to say that you have a cool model, it is not necessarily going to take you to any path you want to go. And as Jordan would say, I would say it's better to try to do less and do it in a really quality way than to do more, especially with AI, especially at the beginning, while you're trying to understand how your data is sort of coming in and going out before you understand sort of how you're going to use it in an organization, contain it, evaluate it, put metrics around it, and then start growing it. And then decide on where you want to position yourself. How much AI are you going to integrate into your company? Are you going to become innovative in it, or are you just going to sort of wait until products come in? And I think that this concept of sort of buying, the buy versus build paradigm, right? I think the time that we're in has completely changed the way that we have to think about the buy versus build trade-off. Not just because of the speed, but I think because of the complexity. I think there is this desire to just like push a button and get a model to run. We saw so many workshops essentially where you could push a button and simulate protein predictions, right? Or push a button and run a large language model. And it seems very tempting, but I would have to say that outsourcing your competency is a really dangerous game, which is why I think Adam said the concept of stop outsourcing to consultants, not in the sense of like stop seeking help, but stop outsourcing your understanding of the problem, hoping somebody else will. So understand your own problem, hire someone who has the technology, fine, partner with somebody, fine, but make sure you know what you're doing internally. And I would have to say that I got really into AI ethics, maybe a year or so ago. And the one thing I would say to everybody is that it is, I don't know, everyone's talking about it in a way that is so useless, right? And so it becomes really frustrating because it's a really important concept. But when we all sort of like talk fluff and not fluff, like I guess international frameworks for AI ethics are not fluff, but they certainly lack actionability to your teams, right? But I guess what I've realized is that the actionability to your teams is your responsibility. So what you're not going to be able to get is to have a framework that someone developed for your company of how to integrate ethics or sort of any other nebulous concept, but it is very important. And I think it will set apart leaders who actually take the time. It's just like FAIR, right? So if you take the time to actually make FAIR or ethics concrete in your organization, it will serve you, even if it's sort of still a little bit nebulous, but unique to your teams. And then let scientists be scientists. And the one interesting thing, a conversation that I've had, and I'm kind of curious on the feedback you guys will give me with this idea, is that I actually would argue that there's no one who values data inside organizations. I think scientists, having been a scientist, value their idea, right? They value the concept they're trying to propagate. Yeah, they gather data for the sake of their idea, but I would say as a scientist, I would be happy to throw away 75% of my data if it doesn't prove my idea, right? And then IT teams don't necessarily value data either. They value perhaps technology. Data scientists value novel methods, right? And so there's no one who actually values the data itself if you think about it. A lot of people talk about data, but no one really cares. And I think we have to restructure our team that the data itself has value. And you also have to think about that even if you're not going to be a leader in the field, you will have demands. Although a lot of these models are free, there's going to be costs associated with sort of implementing them. How many of your teams are going to run these models and simulations? I think we saw from the protein folding prediction, they had AlphaFold that was going to run and was going to take 12 hours. Okay, well, how many of your teams are going to push a button, AWS, run simulations for 12 hours, right? And how much is that going to cost you, even though the model is open source? And then the other thing I would say from the perspective of a scientist is that we have to release this pressure, I think, on scientists to employ these fancy methods, right? And oftentimes what happens is there's this one publication that we hold on to that has some very cool method. And sort of like with trepidation, we take it to a data scientist and we ask them to please deliver us, the same results or similar results. And this is not as simple as it sounds, and also sort of unfair to both sides. And I guess I would have to say that our strategy within our organizations cannot just hang on to this one tiny bit of potential factuality to drive our research. And then the other thing I would want to say is that I think it's going to be actually a really fun time. I think it's going to be really cool to be smart again. And instead of being an influencer, I think it's going to be cool to be highly intelligent and highly discerning and highly inquisitive. And because these models are meant to augment our intelligence. And so in theory, if we actually gain intelligence about our data, it is going to exponentially increase that discovery. And so teams that are actually willing to invest in competence internally and discernment, I think, are going to have a fun ride. So thanks a lot.
Waiting. Okay, so I think we're live. Yeah, there we go. Awesome. All right, so thank you, Adam and Anna. That was awesome. I hope that you're nice and soaked from all the data that we spread at you just now. And we do have about 8 more minutes if people have questions. We've got these lovely microphones we can throw at you. They won't hurt, maybe.
This was Chris Dagg's favorite part of Trends, being
was.
able to chuck these at people. So
if y'all have comments or questions, raise your hand and we'll try to reach you with these things.
nobody.
Anyone?
It's afraid of the cube.
Yes. Going once? Okay.
Yep, oh, back there.
That's going to be.
Oh, boy. All right, all the way to the back.
All the way to the back.
Do it.
All right. Whoops. This is your water. I'm already dropping stuff. Ready?
Ah,
It's okay.
Yeah.
Yes! Yep.
Talking
Were
to
you
the other
speaking
side.
to this one? or
Yeah.
There you go.
Okay, that is an excellent way to wrap up this wonderful conference. What I particularly liked is each of you have really highlighted the real problems in pharma. Active disclosure from Janssen, and again, an active disclosure, I'm from MIT. And what really bothered me most, except for one or two sessions where they talk about AI ML, the math is completely wiped out.
Yeah.
And if you don't understand your math and statistics, how the hell are you going to understand anything about it? And the problem is the leadership in our industry wants to make everything look very simple.
Yes.
And the moment you don't package things and in a very simple way, they have lost you. And I lost my grants. Okay, that's the question.
We hear you and we understand. Yes.
And
Thank you.
yes, we validate that quite a lot. Anyone else?
Or
You can throw it to the next person.
Who else has a gripe with AI?
6
ML?
minutes. Airing of grievances.
Hearing of
Thank
Yes.
you. Thank you for interesting presentations. I have a question. What is your opinion about the usage of those fancy tools broadly in science in comparison to individuals who might find the methods and try to look for new tools or new opportunities, new labs to progress in science, in real and get real science? For me, it's like we are talking about flights or airplanes. Everyone can fly, but to really, if you like fly, you do your license and you explore on yourself. So how much we may observe the democratization of science through the IT, and that's maybe why this distance is appearing between IT and science, because we are too much focused on technology and not for individuals who look for individual methods to solve individual problems.
I think there's a lot of actually really interesting points in that. And that is the difference sort of between teams or individuals who are experts in AI methods and where they would like to go, right? So the development of novel methods, novel tools, because they're also scientists, right? And the rift between a biologist who would like to use a boring method, right, to do something because they haven't even done that, right? And so you sort of see both sides going this way, right? And it's hard to have them come towards each other. What I like to tell scientists is when you take your boring method to a data scientist, it's like asking you to run a gel or an agar or something like that, right? It's boring to them, but they will do it in collaboration. It's important. But you have to also understand that they are also scientists. So we do have to sort of come towards each other. But then those teams who are really experts, they do have to be given the freedom to develop novel tools and methods, if that's sort of the direction of the question you're asking, right? And that is actually going to be our expertise. And so I guess there's a distinction between teams who are experts. They're going to be able to take on novel methods for very complex problems. Teams who have basic expertise and or are willing to lend their expertise to those who are not knowledgeable are going to be able to use standard methods to improve science in a way, right? And we have to allow both to happen. Did I make that too complicated, or is
that's
that
good.
about right?
No.
I've got something to add, actually. Expanding this out one layer, I mentioned it super briefly in like a bullet, but part of the issue that you're talking about actually is the accessibility of science in a lot of ways, right? Cool methods, boring methods, proven methods, which are super important.
Yeah.
Everyone likes shiny things these days because you can post it on Instagram or whatever. But at the end of the day,
Ari, I don't know who's posting AI methods on Instagram.
I've seen it. I've seen it. It's rare. It's only you.
Yeah, I do have an AI ethics account on Instagram. That's true.
She does. But the bottom line is that one of the big problems. So one of the dreams that I have is that data sort of is universally interoperable, right? And that unification across the industry happens. If data are all available and ready for analysis, and the methods are equally accessible to sort of the long tail of scientists, even stretching out to citizen scientists, right? People at home. I mean, those people, like, those come at things totally differently than any of us who are classically trained will, and really interesting things can come from that. I think that accessibility and equality in being able to get to these things is equally important to this as well.
Yeah, I agree, but I think that important is also not to let individuals to be in the shade of those methods, because from my perspective, every scientist is like a surfer can find their best wave, and the wave is not the popular method. It's individual.
Yeah.
Individual
Well, that's the whole point of
assessment.
science. I mean, data scientists are scientists also. We forget that. We think that they're just meant to do our bidding.
And the other way around. Data science is science. Science is data science.
Yes,
Agreed.
fine. Yes,
Yes.
great. Yeah.
Yes, let's
Yes,
unsilo
agreed.
those things.
Yeah.
Agreed.
I don't even need the mic.
As the sole data scientist in the room, yeah.
Yeah, but
All right.
related to that, I mean, I have a lot of questions, but it's okay. Related to that point, like, you can't necessarily get that stuff published, right? And like, no one in this room actually has control over that. I don't know if you all get to review papers or how much time you invest in reviewing papers or that proliferation of information, but that still drives science. And maybe folks here at companies, and that's not what you do, and you do patents and stuff, but you have to navigate that to get those ideas out. And it's not clear to me that the best ideas, if they're not shiny, are actually making it out for general consumption, because there's too much shit out there.
Right.
Yeah.
You have to sift through it all to find that nugget. And so how might we do better? I'm
Yeah,
not sure.
especially in publications. I agree, especially because publications drive so much of what we consider possible, right? So, yeah.
We've been beating the drum of, like, going more towards a concept that's been around forever, like micro publication systems, where people can put their own part of the information out there, link it together, have it sort of publicly peer reviewed in sort of a I'll say the Amazon Marketplace star system, right, or something like that, right, where it's sort of self-evaluated, and then you can cobble it together into official publications later. But it pushes the accessibility, the availability out, and possibly unifies the semantics of something like that, so you can sift through it a little bit.
Yeah, but de-risk that for funders, right? The people who are actually having to make the decisions that then have to go to Congress and justify what they've done so that you can continue getting science funding. I know people probably don't like paying taxes, but it's super important for like the public science industry. And so, what they rely on, it's sort of the same thing when you think about your Congress people, right? Like, they've got a bunch of aides around them, like, trying to sift through information to figure out what the right things to do are, because not one person can be an expert. Like, it's the same thing that program managers are trying to deal with when they're trying to make a decision about what to fund. And it's also just like standardized tests. Why don't we move away from standardized tests? Because like, it's too hard to actually do an evaluation based on other stuff. So the question really becomes like, how do we put additional data and tools into the hands of those people making the decisions about the money so we can see the outcomes that we want?
Yeah.
And I don't know that micro publications would really do that.
Well, we do have to clear away some of the fluff, right? Clearing away some of the fluff is one of the ways to get to clarity, right? Because if anyone can now generate nicely sounding text, then perhaps that's, you know what I mean? That's essentially what reading publications is, right? Reading someone's nicely elaborated text. Maybe we do have to think of we do have to think of ways to clear some of that out so people can actually see the validity of the data and the results and the models, et cetera, et cetera. I mean, how?
Also, Kirsten, you're on the panel next year. So.
No.
I'm willing to just let you keep talking to this guy.
Let's go to the bar, guys.
Yeah, amen. The one thing I was going to add, I mean, economics is the measure of outcomes, but recognition seems to be the measure of insight. And that's a very different sort of, when you stop and think about that, like if you're applying this stuff, I can put a metric on it. But the metric that we put on insight is so nebulous.
Right. That's what I'm saying. No one really values data, right? People value their idea or the recognition they get for their idea. It's a very egocentric metric.
Right. Well, how do we make it though? Because we can see how the application results in the economics as the metric
Right.
of it.
It has to be incentivized.
How do you incentivize?
I don't
it?
know, but it has to be
That's
incentivized.
that's
Yeah,
the
I don't know.
question
We have
we
to
all
do
got
like
to figure.
We figure that
Singer,
out, we'll
but
be
for,
the best
for
company in the
science,
world.
where no one has their name
The,
attached to
the
it.
masked
You know?
singer
Yeah,
scientist has to get up
yeah.
on stage
Like
when they
Shy Panda
present.
submitted this publication, like nobody knows. Yeah.
Read your paper like poetry. Don't put the audience to sleep. Something, I don't know.
Or your
What
rap
happens
song.
when we start publishing negative data?
Well, who said something?
Yeah.
Sorry.
Sorry, what?
What happens if we start publishing negative data and fun things like even
Oh.
if you don't get something right, but to show the world that, hey, we tried this didn't work.
I've been on that soapbox for as long as I've been a scientist, which, arguably is since 2000, because we end up duplicating a whole lot of bad science because we don't report what didn't go
Right.
wrong. It's just as important to understand what didn't work as it is what does work in order for progress to move forward. Failure is not negative. Failure is learning and moving forward.
Why
so,
do we build?
So that's my follow-up question is, in your presentation, which was amazing and incredibly intellectually honest, by the way, we talked about how data costs a lot of money to store.
Yeah.
And I think you mentioned, as a scientist, if it doesn't support my hypothesis, I don't really care about it. So when we have to juxtapose the cost of storing negative data,
Yep.
right, and maybe it's not immediately valuable for someone who's generated it, and sometimes when I look at my old data that didn't work, it's like, oh, I failed, right? It wasn't right. How do we juxtapose that for organizations to actually commit to placing value in negative data or data that didn't work?
Well, I mean, it's a universal problem, right? I think we do have to start understanding what the value is to begin with. And yeah, there could be negative data that's super valuable because you can build models on what not to do, right? But if there's just sort of this negative interspace of data that really isn't useful any direction, let's dump it,
Yeah.
right?
I guess it depends on why we can consider it negative data, right? So sometimes you get poor outputs from a machine. I don't think we
Yep.
need to keep it, right? If there's essentially a flaw. If it's data that provides information, but not the information we're interested in for our publication, then I think it is very relevant context to the data that perhaps we're not using. But if it's quality data, just not the kind we wanted, then I think it actually, and our goal is to use more AI ML models, then I think we need negative data to actually appropriately train models,
Agreed.
right? Because we need that context. I used to work in crop sciences, and one of the problems was that they kept publishing only the top 1% of 1% of data, and then you're not going to train any kind of model on that, right? So perhaps as we go into this field of more AI ML models, we will value data that is counter to our hypothesis because it actually strengthens our hypothesis.
All right, we're getting the hook. It's 6 minutes over. Everyone needs to go to the bar. Thank you all so much. Really appreciate y'all sticking around.